So we are taking a peek today at the first quiz preview in Unit 2. Top says it all. Exponents, factoring, and functions. We're going to start with the exponents. And as you'll notice, we've already got a couple problems done on here. We started to look at this yesterday. But I'm going to take a quick moment here just to review one more time why we've got this going on up the top. When we're doing these, sometimes one of the problems with dealing with exponents can be there's too much stuff going on, and I'm not sure where to start, and I get confused in the middle. So we talked a little bit about an order that we could take things in to make this a little more sensible and not make as many of those little mistakes. We talked about how when we do power to power, which is where we see the parentheses, if we do those first, where we're distributing and we're multiplying the exponents, we get rid of all the parentheses. Then if I see any negative exponents still, we're going to flip those because it's much easier to deal with positive numbers than negative numbers. And then finally, then we can do our multiplying and dividing. Because at that point, now everything's positive, it should be easier for us to not make some of those little mistakes. So with that in mind, when we kind of come back to number 1 here now, I notice there's no parentheses. Don't have to worry about the power to power, number 1. Negative exponents, though, I do notice one. And I'm going to sound like a broken record because I think I said this 2 or 3 times yesterday as well. But if you see a coefficient, a number, or a variable without an exponent, put the 1 on there just to remind you that it's there. Because then when we're trying to figure out, okay, does something stay or does something flip, there shouldn't be much of a question. Positive exponent stuff gets to stay. Even more of a reason why I put the 1 here. This negative 3 doesn't go with my 3 here. There's no parentheses. So my 3, or my 3 to the first, stays right where it's at. But my n to the negative third is going to flip down to the bottom. But I'm not quite done. Because for me to be done, I shouldn't see multiple of the same variable anymore. And I still see n's in multiple places. So my 3 is going to be left alone. When we're dividing, we subtract the exponents. 4 minus 3 is 1. The bigger exponent is in the numerator. And so I can either leave it like that, or if you want to put 3n over 1, either one's fine. And we kind of roll that way. And like I said, 2 we chatted about yesterday, so I won't say a whole lot more about it, but there's a lot of similarities to number 1. No parentheses. We did have negative exponents that we had to flip, though. And then we did the division just like we did here by subtracting and putting our answer where the bigger exponent was. Nothing new. Number 3, still kind of going along that same thing. I see negative exponents. I see terms with no exponent. Got to fix both of those. So I'm like, all right, so 3 gets to stay. Y to the first gets to stay. X to the negative fourth flips. X to the negative third flips. Y to the negative second flips. So I got a lot of stuff going on this time. So here, okay, 3 is my only coefficient, so it's going to stay right where it's at. My x's are on the same level. So I'm multiplying. I'm going to add their exponents. And notice they're in the denominator. Don't flip them up to the top. There's no reason to. And then my y's, though, we're dividing. One's in the numerator, one's in the denominator. 2 minus 1 is 1. Bigger exponents down in the denominator. Then I'm done. So it is. If you kind of just keep things in pieces, it shouldn't be anything that's too bad. Okay, the negative 1 here distributes through to the 2, the y, bless you, the 2 and the x, because they all have exponents of 1. So I end up with 1 times negative 1 is negative 1. Lots of negative 1's coming here. So all those 1 times negative 1's turn into negative 1s, and you're like, holy cow, dude. They all have negative exponents. So what's going to happen? Every one of them is going to flip. But there's got to be something left in the numerator. So if I get rid of everything up there, I've got to make sure I get a 1 up there. Because otherwise we assume all that stuff is up top, and it's not. And I guess the only thing I'd have left here is to see if I can combine anything. So let's see. 2 times 2. Ooh, here's our first chance to talk about this today. Coefficients do not play by exponents rules. This isn't 2 plus 2. It's 2 times 2, which would be 4. And then I have my y and my x. And you can have x, y too. That's fine. But that's as far as I'm going to be able to go. And get myself situated with that. And so as I do these, we're just going to keep kind of hitting those same ideas again and again. Okay, parentheses, if I got them, I deal with them first. Distribute the -3. Nothing really going on over here, so I'm just going to rewrite it. But I notice there's negative exponents, so I'm going to turn it into a fraction. Now here, if you're comfortable with negative exponents, you can go ahead and try to deal with them. But I know for a lot of you, that's been causing some issues. So I would take the ones with negative exponents and flip those to the bottom. But I'm not quite done yet. Because I still notice, okay, I got m's in 2 places. We're dividing, so we subtract. 4 minus 3 is 1. Bigger exponents in the top, so that's where we leave our 1. N's, same idea. Except this time my larger exponent's in the denominator. 6 minus 4 is 2. But I've got to make sure that ends up in the denominator. It ends up a little bit differently that way. But we've got to just keep going on this little new order of things that we've got until we get to that last spot. Okay, anything that doesn't have an exponent gets a 1. That 3 exponent goes to every exponent inside the parentheses. Don't mess with the other stuff. I know some of you want to do 2 steps at once, but it really doesn't save you that much time. And more than likely, it's going to cause you to make a mistake, which is going to cause more issues for you anyway. So all I did was distribute my exponent through. At this point, if you wanted to, you could go to the calculator and calculate what 2 to the first times 2 to the third would be. And it'd actually be 2 times 8, which is 16. So I'll let you know where I'm getting that from. I notice I have a negative exponent, so that's got to flip. But it looks like all my other variable terms have positive exponents, so they can stay the way they are. But I notice there's still a little bit of work left to be done. Because here I notice with my a's, we're dividing, 1 on top, 1 on the bottom. 12 minus 1 is 11. Set there. But my b's, they're both on top of the fractions, so I'm multiplying them. 4 plus 6 is 10. And I'm set. Again, if you want to put the over 1, you can. But it's not something that is necessary. So then our last exponent one, and again, after seeing these rules over and over like this, hopefully it's helping out a little bit. Multiply exponents in the numerator, multiply exponents in the denominator. Since we're dividing, we're going to subtract. 12 minus 4 is 8. Bigger exponents up top, so either 8 to the 8th, or if you want to put the over 1, you can. And then number 8 we talked about yesterday. Again, mainly distributing my exponent through, multiplying power to power. and then just doing a little bit of simplifying. So as we get ready to move to factoring, and we did these first two yesterday, I'm just going to kind of pump this through with a reminder. Okay, the tan sheet, they still are tan at this point, I believe. We're always going to look first to see if there's anything in common that we can factor out. We saw that in number 10. They both had a v. I took it out. Then I basically just start looking to see what's left, if that's the case. If not, then I kind of follow my flow chart here to see what type of problem it is I'm having and how I'm going to tackle that. So we'll actually start doing that here on the back with some of them. So, all right. Always check my golden rule first. First two have v, last one doesn't. I cannot take a v out. Nothing goes into 17 and 70 nicely. Okay. So, we're at a trinomial. My lead coefficient is 1. There's no number in front of my v squared. So we're looking at this like we would a diamond problem, which again is multiply to get the number on the end, add to get the number in the middle. So I get my parentheses set. I get my v's in the first slots. And my next job is to see if I can figure out in advance what the signs in the middle are going to be. Well, it's easy on this first one, because I see plus here, which means they're either both plus or both minus. Those are the two ways I can multiply to get a positive. But the sign in the middle is plus. So I know they're both positive. So now it just becomes, I need two numbers that multiply to 70 that add up to 17. You can use the calculator, you can use your brain if that's something that works for you, but you can also use the chart. So let's say I'm using the chart. Okay, I see a 70 here. So 5 and 14, I jot those down. But then I look, 5 plus 14 is 19. Okay, that one didn't work. I look, okay, there's a 70. 7 and 10. 7 and 10 add up to, hey, 17, all right. You can press buttons into the calculator and divide in. You can use the chart, well, you know, whatever it is that happens to be your need on that. It's number 12. I can't say this enough. Okay. Do they have anything in common? Well, I look through. No, they don't. So it looks like we're diamonding some more. So I get those. I get my b's. This time, I have a negative number that I'm multiplying to, which means I'm going to have one of each symbol. So what does that tell me? Well, what that's going to tell me is, if I'm trying to multiply to negative 35, each time I'm going to have one number that's negative and one that's positive. And I'd assume for a lot of you, the first thing that probably pops in your head with 35 is 5 and 7. At least I would hope. So let's jot those down each in one order and see if one of those is going to work. So negative 5 plus 7 is positive 2. Okay, that doesn't quite help me. But negative 7 plus 5 is negative 2. And that does. So negative 7, positive 5, and I'm good. And if you're not sure sometime, once you put them in, what you also can do to make sure on your middle term is you can do your inner and do your outer, and then just add down. And if you get the right value, you know you've done it right. Okay, it's sort of a little quick double check if that's something that could be helpful to you. So we get that set. You're like, okay, this might not be too terribly awful, actually. So then we hit number 3. Now, before some of you go and start sliding and dividing, I'm going to try and help keep your life simple here. Does anything go into all 3 of those? What I would always do on these, if I wasn't sure, I always would take that very first number that's in there, and I'd try to divide it into all of them, or see if it was on my chart, maybe, but That's getting kind of big here, well, the 120. So I take a quick peek and I go, okay, well, I know 4 goes into 4. Does 4 go into 28? Yeah. Does 4 go into 120? Okay, it does. So here's how this would work. I take the 4 out front. It's not gone. I didn't just divide it out completely. It just gets factored out. And then I'm going to divide each of these numbers by 4. So I have k squared. 28 divided by 4 was 7, but the negative's there. And 120 divided by 4 was 30. Okay, but the negative's there. And look what happens. By taking that minute to kind of think about this, this is now what I'm factoring, and it's just a regular diamond problem. I don't even have to do slide and divide. Now, I'll answer the question in a minute of, well, what if I didn't pay attention to that and I went ahead and did slide and divide anyway? I'll show you why that might not be the greatest idea. So my 4 is going to stay. K. Multiplying to a negative, one of each. Adding to a negative, so the negative's going to be bigger. And again, you kind of start thinking about, okay, what multiplies to 30? A lot of you, I would think, could come to 6 and 5. Problem is, negative 6 plus 5 doesn't get me to negative 7. Negative 5 and 6 doesn't get me to negative 7. What's another pair of numbers that multiplies to 30? 10 and 3. Negative 10 plus 3 is negative 7. Hey, negative 7. All right. And I'm set. So let's just take a second here. And we're going to see slide and divide again as we go through. But let's say you just looked at it and said, there's a number in front of me, do slide and divide. Okay. Here's a little bit of a reason on why we were going to want to avoid that. So here's my original problem. And I decide I'm going to slide and divide right away. First problem's going to hit me in the face here pretty quick. Whoa. 480. Hello. Who wants to sit around and figure out what's going to multiply to get to 480? Not this person. Okay? I mean, that could take, I could sit here for the next 2 or 3 minutes on this video and do all of this breakdown with stuff. But I'll kind of give you a heads up and I'll kind of speed ahead here a little bit for you so you can see what probably would occur for most of you. You'd get to the end and you're going to get something that looks like this. If you multiply it out, it gets back to this. 12 and negative 40. Here's the problem. When you go to circle an answer, you'll notice on number 11, number 12, and even on number 13, inside the parentheses, there's nothing else I could pull out. There's nothing else in common. By doing slide and divide here, hey, both of these are divisible by 4. So if I did it with slide and divide at the end, I'd have to notice that and pull the 4 out. 4 times k is 4k. 4 times 3 is 12. And what's the chances of me actually remembering to do this? Okay? Now, if you did it with slide and divide and got to here, if this is, let's say, a 2-point question, I'd probably only ding you for a half for it not being completely simplified. But man, all the work and time you're going to spend there, it's not worth it. So just make sure that you follow the golden rule to not put yourself into a bind where it's going to take that much time for you. Okay? And the same thing on 14. Something in common. Now you may look at where it say 2 at the start, but you can do better than that. We can take out a 6. I can even do better than that. What else do those two terms have in common? They both have a V. Okay. So when I get here, 6 times 1 is 6. I've already got 1 V. I need to get to 2, so I need 1 more. 6 times what gets me to 60? 10. But I've already got the 1 V. I don't need any more V's. And the cool thing here is there's no squared left anywhere. That's all I can do. Sometimes all I can do is take out the common factor. Okay? But you always want to check, but otherwise, that's all you can do. Okay, 15. All right, 15. Let me anything taking out of all three things. 3. I'm going to save myself a bunch of time again. Because this time, if I divide through by 3, we're back into a diamond problem mode again. I want life to be simpler on you. Run through my steps. I'm like, okay, I should be able to figure out signs here. Positive 6, again, means they're both positive or they're both negative. The middle sign will tell me which one. Both negative. So when I go to do my 6, there's not going to be a whole lot of options. There's 6 and 1, there's 3 and 2. Well, negative 6 and negative 1 gets me negative 7. That didn't work. I guess it's this one. Negative 3 and negative 2 is negative 5. Negative 3, negative 2. Okay? Signs are important. You've really got to watch for those. That's why using little clues at the start to get those signs really, really can be helpful. All right, let's see what else we got here. 16. Anything in common? R. Okay, not a number this time, because 3 and 4, not so much. So here I need the 3. 1 R, I'm trying to get to 2. Over here, I've already got the R. I just need the 4. No squared. I'm good. Again, it gets easier as you practice some more. I promise, I promise, I promise. All right. It is, I believe, slide and divide time again. Because again, I look through. Those two have X's. That doesn't. Nothing divides into 3, 17, and 20. So, guess and checkers. Keep going with it. Okay? You can absolutely get that done this way. Rest of us, we're going to slide that 3 down to the end. I notice right away, everything's pluses, so we'll plus away here. So then I get to 60, and I'm like, 60. All right, so we haven't tried this option yet today, so let's try this one. We can just start dividing some small numbers in to kind of get me thinking. Now, I need them to add to 17, so I know that one's not going to work. Now, be careful. Some of you are going to look at this and go, ooh, 20 minus 3 is 17, which is true, but since the signs are the same, we're having to add here. That's why we've started putting the negatives in our little charts here. So that does not work. 4 and 15 add up to 19, and notice how my numbers, I'm getting closer and closer to 17. So we should be there soon, or like right now. Okay, 5 and 12. But don't circle that. Okay, that would distribute back out to this. So we got to do the divide part. And we've talked about this before. If it divides in nice, 12 divided by 3 is 4. That's cool. We'll just write it in. We're good. If it doesn't divide in nice, 5 divided by 3, 1.6666. Decimals, nope. Math, enter, enter. Hey, it ends up back at 5/3 again. That's okay. Take the 3. Tuck it right in front of your X. And we're good. Again, if that's been your Achilles heel so far, there are plenty of them. Again, 1, 2, 3, 4 factoring assignments. There's plenty of them out there for you to practice still. So if that's your deal, get to practicing. Let's get that better. So then I get to this last chunk. We got some shorties back, our 2-termers. And I look at my golden rule. And I go, hey, they don't have anything in common. So now what? 2 terms, difference of squares. remember this little chart down here at the bottom. Notice the 25 and the 4 are both there. So I would suggest, all right, well, I square 5x to get 25x squared. I square 2 to get 4. And now I'm just going to follow the pattern that's there. And that pattern basically says I take the first term plus the second. And then I take the first term minus the second. And I'm done. So it's not bad, especially when you're going to have this right there with you. And the exact same thing's going to happen on 20. I look at it again and I go, what do I square to get each term? 2 and p. What do I square to get 9? 3. And just follow the pattern. 2p plus 3, first plus second, first minus second. And then we come to the one that tends to throw people off. And I'm not going to say I laugh at this, but I kind of do. People will come up to me even during a quiz and go, Hardy, well, this is supposed to be a perfect squares problem, but 8 and 18 aren't perfect squares. That's true. Did you do what's at the top of the page? Oh, does anything divide into 8 and 18? Even if it's little. 2. If I divide those each by 2, something absolutely shocking and amazing happens. All of a sudden, what's left are perfect squares. Imagine that. Then I happen to notice this time it's the same ones as I had up here. So I'm just going to go ahead and write them out. What do I square to get 4x squared? 2x. What do I square to get 9? 3. Plus. Minus. Don't lose that 2, though, in front. And the last thing I'm going to mention on this page, and some of you are like, wait a minute. Hardy, I'm looking at this same page you are, and I don't see 7 and 8 anywhere. I found out yesterday that I had 2 different sets of reviews run in the same package. One of them had 7 and 8, and one of them did not. That was kind of interesting. Didn't figure this out till later in the day. So if you don't have 7 and 8, just kind of watch in here. I believe the rest of them that are over in the folders now have both of these. But these are the ones where we talk about, is it a function or not? And remember, when we're looking at a chart, the question here is, does x repeat? If I look at my x's, and none of them are repeats of each other, it's a function. Okay, simple as that. That's all you have to even consider here. My domain, when numbers are listed like this, not in a graph, we use the braces. And yes, I am going to be a stickler about this tomorrow. You use parentheses or brackets, it's not right. So if it's a list of numbers, my domain is all my x's, my range is just listing off all of my y's. And I'm good. So for number 8, it's basically the same thing. The only thing, again, I'm watching for is it a function? Well, this time, I have 2 different x values that repeat. No good. Not a function. But even with that, I can still write my domain and range. And notice, I didn't write the 2 twice because, well, I already listed it once. And then my range, I have a larger list of numbers to deal with. So when it's a list or coordinate points, do my x's repeat? If they don't, that's good. That's a yes. If they do, that's not good. It's a no. And then I just list those numbers individually for domain and range with braces. Okay, because that's called set notation, and that's when we list individual numbers off. Your opposite end of that is going to be when we flip the page over. Okay. When we get back here, find the domain and range. Is it a function? Okay, remember, when it's graphical and I'm trying to figure out if it's a function, I'm doing the vertical line test. And I'm looking to see, hey, does my graph only go through at one point each time that I'm doing this? And as long as that's true, it's a yes. I've also got to watch with these my endpoints. Are they dots or are they arrows? Because that makes a difference. When they're dots, like they are here, all I'm going to do is find my furthest point to the left, come back to the x-axis, and use that number. Find the furthest point to the right, again, back to the x-axis, and use the x value. Range is the same concept, except we're going bottom and looking at the y-axis to top. Again, not a bad idea to actually draw the line back over to the axis, just to remind you so you're not sitting there trying to use -5 for that and use the x over it again, because we don't want to do that. And so as I roll through these, it should pretty much roll at a certain point. So I start to do my function test. And I'm like, all right, 1 point, we're good, we're good, we're good. Uh-oh. My vertical line's going through 2 points in the graph, not a function. So you could think it's a function if you were just testing over here, but keep testing along just to make sure. And then again, I do my domain and range. Furthest left, furthest right. And it doesn't have to be where the point is. It can be over here even. So I've got to watch it. My range, same thing. It may be a point that's shared, but again, it's the y value, and then at the top, it's still the y value. So you're like, okay, I kind of see where he's going with this. At least if I didn't before, maybe I do now. 1, 1, 1, 1, 1. All right. Domain, left, furthest right. We're kind of getting on a roll here. Range, again, and the order matters. Bottom, go back to the y-axis, to top. And you're like, all right, Hardy, I get it, I get it, I get it. Here on these bottom ones, I'm just going to start listing a little bit because I think you're going to get tired of hearing me going over and over. I do notice here, though, there's 2 spots that it's going through my vertical line. That's a no. My domain goes from left to right. My range goes bottom to top. And I'll mention while we're finishing up these last ones, again, if there's issues here, every one of these concepts on here we've had at least 2 or 3 times. So you do have more practice problems. Or you could grab another copy of this out of the folder over there, try it without looking, and then watch the video or use this as your key. They're really good ideas. So this one's a function. Left to right. My range, bottom to top. And I'm actually going to zip it at this point and stop because, my gracious, I think we've kind of, kicked a dead horse here with the number of times that we've done these. So, okay, when you come in tomorrow for your actual quiz, it will not be this long, okay? Actually, let me take a quick peek here. I think I got your quiz tomorrow. there will be 4 exponent questions. There will be 9 factoring questions. And 4 domain and range questions. So 17 questions total tomorrow on that quiz. My words of advice. Do homework if you haven't to get extra practice. Maybe watch this video again later if there's still some things you're having issues with. But come in prepared and ready to go with this. There's no reason not for this one not to go well for you. Okay? So